Welcome, everyone, to my glowing laboratory. I'm your host, Ignis the Dragon, and today I've got a seriously fiery and fantastic explainer lined up for you all. We're going to unlock the invisible, magical power of heat energy. Let's get right into it. So, are you ready to master the magical secrets of heat? Today, we're going to use our imaginations to actually see the shimmering, vibrating auras of heat energy that surround us literally every single day. We'll learn exactly how this invisible force shapes our entire world.
Section 1. What is a heat source?
Before we can harness this magic, we really have to understand how we find or create heat, right? So, looking at the science definition, a heat source is simply an object that has a higher temperature than its surroundings. Basically, if something is even just a tiny bit hotter than the air or the objects right next to it, boom, it's officially a source of heat. And this is exactly what that looks like in the real world. We've got the warm glow of the sun, right? That's Earth's major natural heat source. Then there's the Earth itself. Its deep underground core is so incredibly hot that it actually heats up water to create boiling hot springs. And of course, there's my personal favorite, a dragon's roaring flame. But, it also applies to something as simple as a cup of hot tea sitting on a table. Because that tea is hotter than the table and the air in the room, it is acting as a heat source.
Moving on to Section 2. How does heat flow?
We know where heat comes from, but how does this invisible energy travel? Well, there's an absolute rule here. Heat always flows from an object with a higher temperature to an object with a lower temperature. Always. Picture it like a glowing, shimmering river of energy transferring directly from, say, a blazing hot stove flame straight into a cold metal pot of water. The hot literally gives its energy to the cold. But here's the catch. This magical flow doesn't just go on forever. Heat only flows from the hotter object to the colder one until their temperatures are exactly equal. Once the hot object and the cold object hit that exact same temperature, they perfectly balance out, and the heat, it just stops flowing between them entirely.
Section 3. Fast and slow conductors.
Let's investigate how different materials handle this flowing energy, starting with the fast ones. Good conductors are defined as materials that allow heat to flow through them quickly. Metals, for instance, are incredibly fast conductors. It's exactly why, if you leave a metal stirring wand inside a boiling potion, the heat just races right up the wand and suddenly it's way too hot to hold. On the flip side, we have poor conductors. These are materials that do not allow heat to flow through them quickly, and because they block that fast flow of heat, we deliberately use poor conductors like wood and plastic for things like the handles of our hot pots, frying pans, and electric irons. That way, we can actually hold them safely without burning our dragon claws. It's super fascinating to compare these. We know metals are fast conductors, but check out these poor conductors. Wood, plastic, polystyrene, and wait for it, air. Yep, air. It's a really surprising fact. The whole reason a woolen sweater keeps you warm is that the wool fibers trap lots of air between them, and since air is a poor conductor, it stops your body heat from escaping out into the cold. The exact same magic is used in polystyrene boxes to trap air and keep your bottled drinks and fresh fish icy cold. Section 4. Things expand and contract. Heat doesn't just flow, it has the incredible power to physically alter the size of objects right before our very eyes. The rule here is simple. Heat gain equals expansion. When an object gains heat, its volume increases. It literally takes up more space. In the lab, if you take a cool metal ball that perfectly fits through a metal ring, and then you heat that ball up with a roaring flame, it expands. Suddenly, it's too big and just won't pass through that ring anymore. So how does this actually help us in daily life? Well, have you ever had a metal jam jar lid that was just way too tight to open? We can solve this with science. By running hot water over that tight metal lid, the lid gains heat. And what happens when it gains heat? It expands. The metal lid gets just slightly larger, loosening its grip on the jar, and boom, it pops right off easily. But remember, the opposite is absolutely true as well. Heat loss equals contraction. When objects lose heat, their volume decreases. They shrink. This constant expanding when hot and contracting when cold is incredibly powerful. It's exactly why clever human engineers have to deliberately leave little gaps in concrete roads. If they didn't do that, the concrete would expand on a hot summer day, push against itself, and just crack wide open.
Section 5. Changing states of matter.
We've seen things expand, but heat can completely change what a substance actually is. Just look at this magical progression. Step 1, we start with solid ice. When that ice is left out on a table and gains heat from its surroundings, it melts and transforms into step 2, liquid water. But we don't stop there. If we put that water on a hot stove so it gains even more heat, it boils and transforms entirely into step 3, steam, just floating up into the air.
And honestly, the most brilliant part? The magic works completely in reverse. If we start with steam and let it cool down, meaning it loses heat, it transforms right back into liquid water. If we take that water and put it in a freezing cold icebox so it loses even more heat, it freezes right back into hard, solid ice.
Section 6, the Big Dragon Summary. All right, my young scholars, it is time for the ultimate review to lock all this knowledge into your brains forever. Let's enthusiastically recap the 5 major rules of heat we conquered today. Number 1, heat always flows from a hotter area to a colder area until the temperatures are exactly equal. Number 2, heat sources are simply objects that are hotter than their surroundings, like the sun or a flame. Number 3, fast conductors like metals let heat zip right through, while poor conductors like wood, plastic, and trapped air block it. Number 4, objects expand when they gain heat and contract when they lose it. And number 5, heat changes the very states of matter, turning ice to water to steam and back again. So, the really crucial takeaway here is that this invisible magic is happening everywhere, literally all the time. Now, I've got a challenge for you to conclude this explainer. Where will you spot the magical flow of heat next? I want you to go out into your own non-magical homes and look for heat sources. Find those poor conductors and try to spot expansion happening right under your noses. Until next time, keep your fires burning and your minds curious.